We are back with section 1.5, segments and their measures. Notice here I have a line. I forgot to put in my arrowheads, but this is a line. And on this line, I've identified 2 points, points A and B. Now, one thing I want to point out to you is that A and B are just the names of the points. They're just labels, okay? They just help us identify the segment or the line. Now, x sub 1 and x sub 2. X sub 1 and x sub 2 are the coordinates. X sub 1 and x sub 2 are the coordinates of this segment. What they tell me is where on a number line or where on the coordinate plane they are located. Okay, now if I want to talk about the distance between A and B, this is how I would write that. I would write A, B. This symbol, anytime you see it, stands for the distance between A and B. Okay? Now I'm going to give you an example on what this distance means. Here's what we're going to do. I have a segment here, segment CD. And segment CD, I want to know the distance. I'm going to say find CD. And when I write find CD, what this means is to find the distance between C and D. Okay, so we have two ways of doing this. Notice we're on the coordinate plane. I can find the coordinate for point C and the coordinate for point D. So let's do that. Since we're on the coordinate plane, notice this would be your number 1, your 2, your 3, your 4, your 5, 6, etc. And on the y-axis, I have 1, 2, 3, 4, 5, etc. So what are the coordinates of point C? Well, first I move on the x-axis, 1, and then I move up the y-axis and I get a 2. So the coordinates for C, I'm going to write them down here. C is at point 1, 2. Okay, and let's look for the coordinates of D. D is at the x coordinate of 5 and then up to 5, 2. There you go. Now to find the distance between CD, we have two ways of doing this. We can just count the squares in between C and D, and you can tell me, well, there's a distance of 1, 2, 3, 4. So I can simply just say 4. And that's it. That's the distance between C and D. Another way to do it is look at the x coordinate of C, which is 1, and look at the x coordinate of D, which is 5. And notice that 5 and 1, I can subtract 5 minus 1, and I'll also get the distance, which is 4. So if this is at point 5, and this is at point 1 on the x-axis, I can just say, well, 5 minus 1, that's the distance between C and D. It's 4. So you have two ways of doing this. You can count or you can subtract. If you're going to subtract, then there's a formula to find the distance. CD is equal to the absolute value of x sub 2 minus x sub 1. Okay? And notice that when I say x sub 2, that would be this coordinate here. And x sub 1 would be this one. And x sub 2 we already said is 5. So I would substitute x sub 2 for 5 minus x sub 1, which we said was 1, which is the x coordinate of point C. And then that would come out to be the absolute value of 4. And the absolute value of 4 is 4. So then we would say that the distance between CD is equal to 4. So there you have two ways of finding the distance between 2 points on a segment, okay? Which of these two ways are you going to use? It depends. It depends on the situation. But it's basically the same thing. Remember, absolute value, we use absolute value because since we're talking about distance, we can never allow distance to be a negative number. So absolute value helps us when we figure something out inside of here and it's negative, we know that the absolute value of that will be always positive. And distance is always positive. We never have negative distances. That's why this formula has absolute value. Let's do another example here on this coordinate plane. I'm going to draw a segment. And I'm going to draw this one vertically this time. I'm going to draw it from here to here. Okay? There's the segment. And let's label this segment EF. Here's E. And here's segment F. I mean point F. There you go. And I want you to find EF. And when I say find EF, this means find the distance between E and F. Now let's do it the short way. The short way would be to count the squares in between E and F, right? So I'll have 1, 2, 3. So find EF. EF is equal to 3. The other way to do it, which I'm showing you because in your book you have some exercises that want you to do it using the absolute value. The other way to do it is to label. We can label this point x sub 1. And I'm sorry, we can label this y sub 1 because now the distance I'm going to look at is not the x coordinate. The distance I'm going to look at now is your y coordinate. So let's look for this coordinate before I label this. The coordinate for point E is, on the x-axis, I'll have -1, -2, -3, -4, -5, -6. This would be -6. And on the y-axis, I come down 1. So this is -1. For this point, F, I'm also at -6 and at 1, 2, 3, 4, at -4 on the y-axis. So here are my coordinates. Now, I said the distance was 3. That's because I counted down 3 units. Notice your y values here. This would be your y sub 2, and this would be your y sub 1. So if I want to find the distance EF using absolute value, I would have to subtract y sub 2 minus y sub 1. And that would equal -1 minus -4. Now that equals -1 plus 4. Remember, anytime you have a minus negative, that becomes a plus. And that equals the absolute value of 3, which is equal to 3. So the distance between E and F is equal to 3. And that's what we had gotten originally just by counting the squares. Okay? So there you have 2 ways of doing it. In your book, you'll have exercises pertaining to this kind of problem where you have to find the distances between E and F. Okay? Now, I'm going to erase all of this. Now we're going to talk about congruence. I have 2 segments, segments AB and segments CD. Now there's a very important distinction that I want to make between these 2 things. When I talk about segment AB, and this symbol stands for segment AB and segment CD, I'm talking about the object, the physical object. I am not talking about how long they are or how much they measure. When I talk about the distance between AB and the distance between CD, remember, if there's no bar above these 2 letters, this represents the distance between these 2 points, then in this case I'm talking about a number. Okay, so numbers I can equal to other numbers. So I can say that AB is equal to CD, and this, what it means is that the distance between AB is the same as the distance between CD. And since these things represent numbers, I can use equal sign. Now, in this case, segment AB and segment CD, since these symbols do not represent a number, I cannot say that they are equal. I cannot say they are equal because they're not numbers. They are objects. So when I want to say that two objects are the same, I use this symbol. It's called congruent. Okay? That's the symbol I use to say that the object has the same length as the other object, but I'm not talking about how much the length is. When I use this symbol, I can say that one number is equal to the other because this one stands for distance in between. Okay, so if two objects, in this case, two segments, have the same length, that means that distances are equal, then I can say they are congruent. And if they are congruent, I can use tick marks to show congruence. Tick marks mean something like this, that and that. That symbol tells me that segment AB and segment CD are congruent. That means that their lengths are equal. Now, you cannot write this. You cannot say that AB is congruent to CD, because here you're talking about an actual number. Remember, when we don't write a bar above AB, we're saying that AB represents the distance between A and B. So this is really a number. We can't say a number is congruent to a number. We have to say that a number is equal to a number. So if you write something like this, this would be wrong. You cannot write this. If I write segment AB is equal to segment CD, this is also wrong because now we're talking about an object. An object, I do not know its length. It's just laying there as an object. But I do know that if I take AB and place it on top of CD, they will match exactly. But I don't know the length. I don't know the exact number length of this object and this object. So if I know that they are equal in length, but I don't know their measures exactly, all I can say is that segment AB is congruent to segment CD, and this would be the correct way of saying that. This would be the incorrect way of saying that. So be very, very careful with these notations. Anytime you use the symbol for segment, you're talking about an object. And objects, you don't have a number for them. Anytime you talk about distances between A and B, then this is a number. If we know the number, we can say that they are equal, but we cannot say that they are congruent. So for objects, we use congruence symbol. For numbers, we use equal symbols. Okay? And there you have it. Let's do an example. Okay, here I have two segments, segments ST and PR, and the figure shows me that they both measure 6. So that tells me that segment ST and segment PR are congruent. They have the same length. They have the same distances. So let's write the statements. I want you to write segment ST congruent to segment PR. How would you write that? Go ahead and write it and then come back to see the answer. To write segment ST is congruent to segment PR, this would be the correct notation. Now, how do you write that they are equal? Go ahead and try that one and come back for the answer. Hit pause. Now, to write that these segments are equal, I would write that the distance between ST is equal to the distance between PR. and that would be the correct notation. I can also go ahead, knowing that they are equal in length, I can use tick marks to show that they are congruent. Okay, so again, be careful with this notation. So whenever two segments have the same length, I can say they are congruent. So I can establish if ST is equal to PR, then segment ST is congruent to segment PR. I can establish that, okay? And this is very important when we start doing demonstrations. If two lengths are equal, then they are congruent. Okay, I will see you in the next video where we'll study the segment addition postulate. I'll see you then.